you don't get enough of me, here we are back in the lab to talk today about the oxidase test. The oxidase test is not a hard test to perform, but it has a couple of little nuances that if you don't do them correctly, then you'll end up not being able to interpret your results. So the first thing that's a little bit tricky about the test is that rather than taking a single isolated colony, as I'm usually harping on you to do, you're going to need to use enough growth on your oxidase test that you can actually see it on the filter paper. So you're actually going to want to pick up quite a lot of growth and put it on your filter paper. So let's start there with some Whatman filter paper. And you just want to place the filter paper into an empty glass petri dish. And then you're going to use a sterile stick, and you're going to take enough growth off of your plate that you can put a little bit onto the Whatman paper and see it on the Whatman paper. Whenever you do this test, you want to have both a positive and a negative control. Your positive control is always going to be Pseudomonas aeruginosa. Pseudomonas will always come up positive because it has that terminal oxidoreductase in the electron transport chain called cytochrome C oxidase, and that's what we're testing for here. So take enough of your Pseudomonas off of your plate that you can see it on your wood stick, and then you should be able to rub it onto your Whatman filter paper such that you can see it on the filter paper as well. If you can't see it, then you don't have enough. You're not going to be able to interpret something that you can't see. That's why this test is so different than any other that we do, because you're actually reading the results right here, right now, and you're not inoculating something and waiting for it to grow. So you're going to want to have always a negative control when you do this test as well. Today we're going to use Shigella dysenteriae as the negative control. But you could use any Enterobacteriaceae. So if you wanted, you could use E. coli or Proteus, or even if you wanted, Yersinia pestis. And again, just take enough that you can actually see it on your stick. And again, rub it onto your filter paper. And you'll want to put it on another corner opposite of where you put your Pseudomonas aeruginosa. Now, when you do this test on your unknown, you're going to want to put your positive control, your negative control, and then you're going to want to put your unknown on a third quadrant of the paper, because this test is extremely time dependent, and so you need to be able to watch the results as they turn. So you would want to always have the three side by side by side. Now we're going to add the oxidase reagent to both the Pseudomonas and the Shigella. The oxidase reagent is a chromatogenic reagent that changes color upon oxidation. So you're just going to want to add a little drop on top of your positive, and within a few seconds after you add these drops, you're going to want to read the results. So add a drop onto your positive and your negative, and bingo. Look at the dark purple color change on the positive, and the negative just simply stays white. But the longer I sit here and talk and kibitz and whatnot, you're going to watch the negative as it starts to turn purple due to natural oxidation. So time is of the essence. You have to read the results of this test within only a few seconds. If you sit around and let it turn, everything is going to look positive. So it's very important to have a positive and a negative control every time you do this, and to watch the results within only a few seconds after adding the reagent.